So let's start off a simple example on hydropower. So here, water falls through a head of 100 meters and drives a turbine to generate electricity. The total overall efficiency of electricity generation is 85%. What flow rate of water in liters per second, that is the unit here, is needed to generate 1 kilowatt of electricity? So let's take a look at what is this problem about. So here, so we have one from a dam. So let's say a dam has a height of around 100 meters, which is given, and this has a water that is flowing coming from here towards down, so that it can power a turbine somewhere here. All right, so the turbine can power this one now to produce 1 kilowatt of electricity. So the height is 100 meters and the power is given as 1 kilowatt of electricity. So let's put it list down here, the given, which is head of 100 meters, and efficiency is given also for the conversion efficiency, which is 85%, and the question is to find the flow rate of the water. So this should be in liters per second, which is the what is asked for this problem. So as a solution for this problem, so I think it's very straightforward. So our solution, as we remember from the potential energy formula, which is in this case, this is a potential energy that is used to drive a turbine. So the potential energy for this is E equals mgh. And so to get the power, so we have power is equal to, what is power? E over T. All right, so that is energy per unit time. So energy is in terms of mgh over time. So we have already the formula for power. So now our question is basically in terms of flow rate. All right, so in this case, the flow rate should be in terms of the mass flow rate here, which we can later on change into volume flow rate. So here we have to get m over t, which is equal to p over gh. So we will just transpose this one under the p. So we will now have, and of course, we need to apply the efficiency as well. So there must be times efficiency here. All right, so in this case, we have to put efficiency here, times efficiency. All right, so we have now the efficiency at the denominator. So power is given. So power is 1 kilowatt of electricity, which is given here. If you can look at here, this is the power over the gravity. So the gravitational force is 9.81 meter per second squared times the head, which is 100 meters, and of course times the efficiency, which is 0.85. All right, so we get that one as we need to solve that one. The result for this is 1.2 kilogram per second. All right, so 1.2 kilogram per second. So our question is to change into liter per second. So how do we change that one? So we can say 1.2 kilogram per second, and how many liters in 1 kilogram? So this is water. So basically water is 1000 kilograms per cubic meter, which is basically the density of water, right? So we can change that one into 1 liter is equal to 1 kilogram. So 1 liter for water is equal to 1 kilogram. So please check if this is actually correct. So in this case, our answer should be 1.2 kilogram. Oh no, 1.2 liters per second. So that is our result now for Q. So this is m over t, or this of the volume flow rate. So we can start from here. So if you remember before, the density of water is 1000 kilogram per cubic meter. If you change that one into 1 cubic meter is equal to 1000 liters. So you can cancel 1000 liters, cubic meter to cubic meter, so it becomes 1 kilogram per liter. So it means that for 1 kilogram is equal to 1 liter. So that's why we can directly change that one into this answer. So 1 kilogram per second is basically 1.2 kilograms per second is equal to 1.2 liters per second. All right.